I'm Itay, and this is Lab 9 diffraction.
Dror, this lab had three parts. In the first part, this was the setup for all of them. The first part, we did a qualitative analysis of diffraction. We used single slits and we used double slits and compared the shapes that were made and the graphs. For part B, we looked at the Fraunhofer diffraction, the maxima, the first and the second, and we compared them to the known values that we have. And for the last part, we used the circular aperture and did the same thing and repeated it to compare the values.
Itay is measuring the distances between the components.
And then
By modifying the distance here, we're going to find the Fraunhofer diffraction.
yeah.
So we can't see the side lobes on this one for the Fraunhofer diffraction. This is the 20 micron setup, and this is the graph, 40 micron, and as we can see now we're expanding the width, and we can see the side lobes are on the side, and this is the graph. This is the 160.
And this is the graph and the diffraction that we have. As we can see, we see a lot of side lobes here.
This is the Fresnel region. This is what we can see, and the graph is at 0.
This is for part A. As you can see, we got 4 different single slits, and we measured each one's distance. They are pretty similar here. As we can see, the distance is very different than the calculated distance, and that because of a modified lens that make it possible for us to do it in lab. To find this distance, we use this equation, the NF, which is where we start to go into the Fraunhofer region. We approximate it as 0.1. This is the wavelength that we know, and the aperture size is the number that we got in the single slit.
Okay, so this is the double slit, the first one, and we see that there is the central and the side lobes. We can see those on the graph.
This is the A500. As we can see, we have the peak right here, and we got a bunch of side lobes, at least 3. It's hard to see them in the graph because they are low, but they are there.
So the number of side lobe increases as you increase the distance.
This is the A500, and as we can see, there are more side lobes than the 4500 and more interference than the 8250. As the distance between the double slits increase, we'll see more cosine modulation within each lobe, and as the width increase, it will squeeze down, so we will see more side lobes in the region that we have.
We can see that the first and second minima are symmetric on the y-axis.
Here in the sum squared feet, we expect the value to be the value of the maxima to be 0.015, and that's what we got here. We got